Hey guys, so I'm just going to do kind of a quick walkthrough of this problem. So we're given the set of feasible production net put vectors is 0, 0, negative 1, 2, and negative 3, 3. That means we can either produce nothing using 0 inputs and getting 0 outputs. We can produce 2 outputs with 1 input, or we can produce 3 outputs with 3 inputs. And now we want to find this y star vector that solves this maximization problem. So essentially what we want is to figure out the y that makes this value as high as possible, subject to the constraint that y has to be up here. So in other words, we're trying to figure out which of these is optimal. So first, the question we can ask ourselves is what would have to be true for us to choose to produce nothing? If we were going to choose to produce nothing, it would have to be that both of these gave negative profit. It would have to be that the profit given by this one and by this one is less than this one. So we would write that as profit given by 0, 0 is greater than or equal to profit from negative 1, 2, and the same thing for the profit from negative 3, 3. But how can we write the profit from these? Remember, that would be the price vector, that dot product, with whatever vector of y we chose. So we're taking the dot product of the price vector, this p1, p2, with whatever we're choosing from y. And that gives us the profit of this vector. So we can replace this with p dot 0, 0. We can replace this piece over here with the following things, with p dotted with negative 1, 2, and p dotted with negative 3, 3. So this is what would have to be true for us to pick 0, 0. This should make sense because for us to produce nothing, it has to be that that gives us more than both of our other production options. So this one I'll write all the way out, and the other two, when we do them, I'll skip some steps for the purpose of time. But for this dot product, p dot 0, 0 is equal to p1, p2 dot 0, 0. And to figure out this dot product, it's p1 times 0 plus p2 times 0, which is just 0. So we can replace these two with just the number 0. Similarly, p2 of negative 1, 2 is equal to p1, p2 dot negative 1, 2, which is negative p1 plus 2p2. So we replace this part. And similarly here, we get negative 3p1 plus 3p2. This is what must be true for us to choose 0, 0. But we can get it a little bit more simple than that. We can do some algebra here to move this p1 to this side and this 3p1 to the other side. So we can replace these with p1 greater than or equal to 2p2 and 3p1 greater than or equal to 3p2. Next, we can, on this one, we can divide by 3 on both sides to get this. And now, in both, we can divide by p1. So we get 1 greater than or equal to 2p2 over p1, and 1 greater than or equal to p2 over p1. And now lastly, in this top one, we can divide both sides by 2 to get 1 over 2 is greater than or equal to p2 over p1. And these are the two inequalities we get at the end. But this is a bit redundant, because if we're less than 1/2, we're automatically going to be less than 1. because if you're on your number line here, if you have 1/2 and you have 1, everything under this 1/2 is going to also be less than this 1. So it's redundant to have both, so we can just erase this part, and that's what has to be true to choose 0, 0. And now we do the same process for the other two possible production options. And similarly, it has to be true that P dotted with negative 1, 2 has to be greater than or equal to P dotted with the other options. And lastly, P dotted with negative 3, 3 has to be bigger than both of the other options. So this are the three cases. We could pick 0, 0, negative 1, 2, or negative 3, 3, and this describes when we would choose each of them. Now, for the purposes of time, I'm going to skip over the algebra on this part, and I'm going to show you what the end result is when you evaluate these dot products and do some algebra on the inequalities. Here, you get 1/2 less than or equal to P2 over P1 less than or equal to 2, and down here, you get 2 is less than or equal to P2 over P1. And so this is when we would choose 0, 0, this is when we would choose negative 1, 2, this is when we would choose negative 3, 3. So that means y star depends on P1 and P2, and it's a piecewise function, meaning it takes on different values depending on what inputs we give it. So we can write 0, 0 if P2 over P1 is less than or equal to 1/2. We choose negative 1, 2 if it's between 1/2 and 2, and we choose negative 3, 3 if it's bigger than 2. And now, the astute among you will notice that there's some overlap. If P2 over P1 is equal to 1/2, both of these are true, so we would have to pick which one of these we want to say. We'll just go ahead and define that we choose this top one, so we'll set this to be strictly less than, and similarly, we'll set this to be strictly positive, strictly greater than. Because otherwise there would be this overlap, and you would get two outputs for one input, which can't happen. So we do this to eliminate that case. So essentially you see what would have to happen in each of the cases, and then you write that this way. And now to find the profit, all we have to do is plug in this y star into this function to see what profit we get from each of these. So I'm going to go ahead and copy this onto the next page. And now this denotes the profit under the feasible set y. And it's also going to be piecewise. And it's going to be P dotted with 0, 0 if P2 over P1 less than 1/2. Negative 1, 2, P dotted with negative 1, 2 if you're between 1/2 and 2. And it's going to be P dotted with negative 3, 3 if you're bigger than 2. And all we have to do is evaluate these. This one evaluates to 0. This one evaluates to negative P1 plus 2P2. And this one evaluates to negative 3P1 plus 3P2. So here we have our optimal y and our profit function. In the next video, I'm going to do some geometric intuition behind this.